Hey freshmen, I wanted to give you some additional examples of simplifying radicals before we advance onto some more complex versions of these problems. So I want you to remember, we'll start with radical 40. The only factors I want to simplify these down into are ones that contain perfect square factors. So if I asked you for factors of 40, I know that factors of 40 contain 8 and 5. I know we could do 2 and 20, obviously 1 and 40 as well. But the only one that has a perfect square is going to be 4 and 10. So the only thing you can do with root 40, or the only thing I want you to do, is to make this into radical 4 times 10. Remember our rule that these can be broken up into their own radical factors, so let's make it root 4, root 10. So before I go on, let's just, again, talk about what these represent. This is radical 4 times radical 10. Radical 4, the square root of 4, is 2. We know that, so why don't I simplify that? Radical 10 is not a perfect square. Does it contain any perfect square factors? The only factors of 10 are 1 and 10 and 2 and 5, so it does not. So that means I need to keep it as radical 10. So this answer is 2 root 10. It represents 2 times root 10, and that's all I can do to simplify it. Root 72. Now 72 has a lot more factors than radical 40. It's not a huge number, so what we want to do in this problem, let's think of the best perfect square factor of 72. I'm just going to run down the list and come up with the highest perfect square factor that we can get for radical 72. Let's start with 4. Is 4 a factor of 72? It is. 4 and 18. Let's see if I can do better than that. The next perfect square is 9. 9 is also a factor of 72. 9 and 8. Let's hold on to that. So at worst, I'm going to use 9 and 8 to simplify 72. Let's check 16. 16, not a factor of 72. 25, not a factor of 72. Then we get to 36. 36 and 2 are factors of 72. So I could have broken this down using 4, using 9, but the best perfect squares here, the best perfect square is 36 and 2. I'll break this down into their own radicals. Square root 64, square root 2. The square root of 36 is 6. Root 2 is simplified. So that's the easiest way to simplify the square root of 72, finding the best perfect square there. Let's do 2 more. Square root 125. Little tip, if you ever see a 25, a 50, a 75, or anything that is ends in zeros, it's going to have a perfect square factor of 25. Best perfect square factor here, it's going to be 25 times 5. We'll break them up. I know that the square root of 25 is 5, and root 5 stays as is, and I'm done. One more, a little more challenging, this one, square root of 240. So in the example above with 72, I found the best perfect square factor. It had actually 3 candidates I could have simplified it into. When you have a bigger number, you may not necessarily want to waste time thinking of the best perfect square factor. You might just want to start with a simpler one. So what is the simplest perfect square I can factor out of a number? Well, the lowest one we're using is 4, right? So instead of looking for the best perfect square, let me factor this into 4 and whatever its other factor pair is. If I divided 240 by 4, that would give me 60. So let's just break this up. Let's make it root 4, root 60, and I'm going to turn that root 4 into a 2 root 60. Now it looks like the previous examples we did, but we have to make sure that all of our radicals are simplified in order to say that we are done. Root 60. Does it have any perfect square factors remaining? 4. Right off the bat, we see that's a factor. So I'm going to factor out root 4 again. Root 60 can be defined as the square root of 4 times 15. I'm going to make these into their own. So I still have a 2. Another root 4 is another times 2. Root 15. Now it's got factors of 3 and 5, neither of which are perfect squares. So I got to leave it. So to simplify this one, I'm just going to multiply the 2's. 4 radical 15 is your final answer. So hopefully some extra examples here will help you with your assignment.